Hi, okay class. Assalamualaikum and good day everyone. So we are into week 3. So week 3 we will continue with the we are still in chapter 2, which is probability. So we have another one subtopic, which is the rule that we will apply. Okay, so we have two rules here. You can see we have okay, we have two rules, multiplication rule and also addition rule. Okay, darab dan juga tambah. Okay, so for the multiplication rule, so we will apply or we will implement the multiplication rule when the property of the intersection of two events. Okay, maksudnya we will apply multiplication rule when we get or we have a intersection of two events. So this is the equation. So this is what I mean by intersection. Okay, this is the symbol. Okay, so probability A intersect B. Okay, probability of A intersect B. So this is how we find the intersection or the multiplication rule lah. Okay, so you can see that they have the what we call the conditional probability here. So yeah, it will be relate with that. So you need to know the equation of the conditional probability here. So okay, maybe I can write down here PA given B, okay, or P, okay, because this is PB given A, okay, but I will give you PA given B. So this one is equal to, okay, this equation is equal to P probability of A intersect B. Okay, I'm sorry, okay, class, because I didn't have any device, because I expect that we have face-to-face class, so I didn't prepare the device for this. Okay, so I just write down here. Okay, and then PA intersect B over, okay, over what? Over PB. Okay, PB, not the letters, this one. Okay, the given that of event here. So PA given B is equal to PA intersect B over PB. So if PB given A, so you will have, okay, you just switch lah macam ni kan. Kalau sini PA given B, so A intersect B. For this one will be B intersect A. But B intersect A and also A intersect B will be give the same value. Maksudnya A intersect B dengan A intersect B and also B intersect A will be give the same value, tak ada masalah. But for what you will over with P A lah. Okay, for this one you will over with PA. Okay, kat sini kan dia punya yang belakang ni A kan, so you will divide by PA. Alright class, so it doesn't matter actually. It doesn't matter, for example, and the question is intersect A intersect B. Actually, it doesn't matter you want to solve or you want to do it B intersect A or you want to solve or you want to do it A intersect B first. Tak ada masalah. The answer will be the same. Okay, later I will show you the example, okay? Alright. Okay, so just accept lah for the multiplication rule PA intersect B. Okay, we will use when we have intersection. Alright. So now, for the second one is addition rule. So addition rule we will use when we have the union. Okay, union. Okay, this is a symbol for union. PA union B. Okay, so this is the equation. PA, probability of A, plus, okay, because this is addition, right? So plus PB minus PA intersect B. Yes, they have intersect here. Okay, alright. Okay, so this is the formula. Alright, so now we go to the multiplication rule first. So for the multiplication rule, okay, we have two events here. We have mutually exclusive, right? If you still remember, we have mutually exclusive event. And we also have the independent event. So if A and B are two mutually exclusive, then your equation for P intersect B is equal to 0. That's it. They have no given A, given B, and so that they have no that one. Okay, we just PA intersect B, automatic it will be equal to 0. Okay, so means that if you have a question that involve with mutually exclusive event, so it will be simple. PA intercept B will be 0. Then we have also independent. So if A and B intersect of two independent events, so PAB, it will be equal to PA times PB. That's it. Okay, maksudnya dia tak ada kaitan. They have no relation with this equation. Okay, so this okay, so means that the general one, this one, the general equation is this one. But when you identify your equation or your event is mutually exclusive event, so you will use this as your equation formula. And if you identify that your event is independent, so you will use this as your formula. Okay, no longer that one lah, no longer the before, the just now. Okay, that one is for multiplication rule. So now we go to the addition rule. For addition rule, so same thing, I divide it to two mutually exclusive event and also independent event. But class, for independent event, they have no, they have for the what we call for the addition rule, they have no independent event. Okay, right? So for mutual exclusive, so when it's A union B, so we just have PA plus PB. Because of what? Because of, okay, you can see, refer back here, because A intercept B is equal to 0, right? If it's mutual. So this is, suppose, okay, kalau, okay, we go back for the original equation here. Okay, PA plus PB minus PA intercept B. Then we already said that the formula already said that if it's mutually exclusive, PA intercept B will be 0. Therefore, this one equal to 0. That's why we just left with PA plus PB. Okay, class? Alright, so hope that you clear on that part lah. Alright, now, okay, I give you an example here. We will try to solve it. So example 1 here. So this from the 3 suppliers are analyzed for surface finish. So whether the surface finish is excellent, good or bad. So we have supplier 1, supplier 2 and supplier 3. So what I suggest you to do first is you total up all the value here first. Okay, for example, okay, for the what's the total for supplier 1 here? Okay, means, okay. Okay. I will use, okay, so the total of for supplier 1 will be 670. Okay, you just add on all this for supplier 1 only, for supplier 1. For supplier 2, you will have 375. And how about the supplier 3? The total of it will be 570. Alright, so that one is the total for each supplier. So now you find out the total for each of the surface finish. What's about the excellent? You have here 200, 200, so you have 400 here. Okay, it will be 400. How about for the good one? So it will be 1000. Okay, it will be 1000 here. How about for the bad one? It will be 2115. Alright, class. So we are already total for each of it. Now, find out the total for all. Okay, if you sum all these three values, you will get 1615. Okay, 1615. So you need to recheck again whether it's 1615 or not. So you sum all this value also. This one. Oh, sorry. Oh. Okay, you sum the 400, 1000 and 215, so you will get also 1615. Alright, so now we go to the question. So the question asks you to determine the probability of supplier 1 and good. Okay, class, one more thing that to differentiate between the multiplication rule and addition rule. The keyword here is and. If the word here is and, so it means intersection. Okay, when the word is and, okay, let's say I just write down is probability of S1, okay, supplier 1, and so and I denote it as a intersection symbol. Okay, so please remember, if you have a word and here, so it means intersection. And okay, I denote G lah as good. Alright, class. So find out the probability of supplier 1 intersect good. Okay, or and good. So so the formula will be P, okay, probability of S1 given, yes, it's just conditional probability, right? Given G, and then times with what? Times with probability of G, yes. Okay, we will multiply with the given one lah. The given one here is G, good. Okay, so you find out all these values. So PS1G, so means that you find out, okay, where's the S1? So this is your S1, and then this is your good. Okay, so this is the value that you're supposed to take lah, 450. Okay, 450. Okay, because this is probability class, so must be over something. Okay, this is over what? Over the good values. What is the good value here? 1000. Okay, the good value here is 1000. Okay, then how about the second one? PG. PG means the probability of good. Okay, the probability of good. Okay, 450 is not probability of good. 450 here is a probability of supplier 1 given good. Okay, you want the probability of good only. So the probability of good is this, 1000. Yes, 1000 is the probability of good, the value of the good. Sorry class, my bad, my handwritten is so bad here. Okay, I hope that you understand, or you just listen to my voice so you can understand lah. Right, so 1000 over the total value of all, which is 1615. Okay, so you can cancel these two because it's equal, right? So you will get 450. Okay, 450 over 1615. So that will be your answer. Okay, or you can simplify 450 over 1615 using calculator. You will get 90 over 323. Okay, class. So maybe some of you will wonder or will ask, Miss, can I switch these two? Means that macam mana saya? Okay, saya padam balik So I will erase all this one first. Okay. Maybe some of you will wonder or will ask me, can we, okay, just now we use S1 given G, so can we use G given S1, and therefore we will multiply with here with B, or probability of S1 lah kan? Okay, because the given one here S1. Okay, so now you can see that the different here, I switch it. Okay, right. So how to answer this? Okay, for G given S1, it will be the same. Okay, because G given S1 is still 450. So 450, but now you will over, not over 1000, because now you will over with the probability of S1. So what's the probability of S1? 670. Okay, 670. Okay, now next, the probability of S1. Probability of S1 just now is 670. Alright. Over. Okay, you must be over with the total of this, which is 1615. And you can cancel these two figures, 670. and you will get the same one, 450 over 1615, which is equal with the previous one, is it? That's what I mean. Okay, it doesn't matter you want to solve which one first. I mean, not which one first. It doesn't matter you want to choose G given S1 or S1 given G. It will give the same answer for you. Okay, class. Okay, I hope that you can find out the others too. Okay, it's just follow the previous A here. But okay, for C, I will show you. For C, you can see that this is a probability for supplier 1 and supplier 3. So P S1 intersect with S3. Okay, class, see carefully. From your table, is it S1 and S3 can intersect? Boleh tak? Ada tak? Macam maksudnya kalau for example here, S1 and excellent, yes, can. You can have a figure here. S2 and bad, yes, you have 65. But how about S1 and S3? They have a value or not? No, they have no intersection happen between S1 and S3. Therefore, the probability of S1 S3 is 0. Okay, means that S1 and S3 is not a mutually exclusive event. Okay, it's a mutually exclusive event because they have no intersection happen between these two events. Alright? Okay, class, so another one example. So, the probability that a sample of fly ash contains sulfate is 0.8. And then the probability that this sample contains calcium is 0.738. And the probability that this sample contains both. Okay, both. So, okay, we will write here. Okay, saya tulis dulu kat sini. Let's say I let S as a sulfate and C as a calcium, okay? So, the probability of sulfate is given by 0.8. Okay, 0. Allah. I'm sorry, class. Okay, 0.8. Okay, for what? Calcium. Probability for calcium, if it is 0.78. And probability for both. For both mean intersection lah. So P S intersect with C. Okay, or C intersect with S. It doesn't matter which one you want to write first, but it still give you the same probability, which is 0.75. Okay, 0.75. So now the question asks you to find the sulfate given that. So probability of sulfate given that the sample contains the calcium. Okay, so class, so this equation will be equal to P S intersect with C. Sign intersect dia. Okay, P intersect with C. Macam budak tadika baru tulis sorry. Alright, so P intersect with C and then divide with the PC. Okay, divide with the probability of C lah. Okay, so all this information you already have it here. So PSC will give you 0.75, and the probability of the calcium is 0.78. And then you will simplify. Okay, using calculator you can simplify, so we give you the answer will be 0.9615. Okay, if you have a decimal point, and you may write the decimal point. Okay, so 0.9695. Okay, next for B. Okay, for B you can see that it asks you calcium given that sulfate. So dia is switch. Bila switch, the intersection will be equal. Okay, tak ada masalah. Intersection will be equal, the same, but what you will over with the sulfate. means that 0.75 we will over with 0.8. Okay, so you will get the answer lah, 0.9375. Okay, so basically the answer or the steps, okay, if you want to see more proper, kalau you tak faham my handwritten here, you may refer to the notes. Okay, alright, so I proceed to the next example here. Okay, class, so this example, okay, the last one, not the last one, the second last. Okay, class, so I think I missed out one more example, but okay, it's okay, we just focus this one first. Okay, Azila will be having 2 midterm exam in a week. Okay, the probability that she will pass an Islamic civilization subject. Okay, I write this one as a PI. Okay, I represent as Islamic civilization. Okay, so this one is equal to 0.92. Okay, 0.92. Alright, and then the probability that she will pass an IT subject is assumed is 0.88. So IT subject I denote as is T. Okay, it doesn't matter which one that you want, which you want to use any alphabet also. Okay, but as long as you understand lah what you like. Okay, this one 0.88. Okay, so the question okay, and then it say that it will be these two subject is independent. Okay, independent class, right? So what's the probability that she will pass both? Okay, means both means you will do the intersection lah, of course lah. So means that it will be P I intersect with T. Okay, P I intersect with T. Alright, so and it says that it's independent class. So now if you are refer back to the formula, the equation here, where it's independent, so it will give you PA multiply with PP. That's it. Yang tu je, tak ada pun nak conditional probability or else. So you just multiply PI, the probability of I, and then times with the probability of T. Okay, that's it. Not plus, times. Darab. PT. So therefore, 0.92 times with 0.88. Okay, that's it. So you will get the answer lah, 0.8096. And the second one, B, she will not pass neither nor. Okay, means that she will not pass for both. Dia gagal untuk kedua-dua. She will fail lah. Okay, fail for both. So the probability that we have is pass. So this is how we write. Okay, if you still remember, we have the complementary event, right? So if I is represent the pass, so we want fail. Okay, we want to fail. So means that P I bar. Okay, I bar or I apostrophe. Okay, this bar is represent the complement for the another one. So which is tadi kita dah ada pass. So now we want to get a fail one. Okay, so it's a bar lah. We did not as bar. So since it's both, okay, both. So means that it's intersection. Okay, with the IT. Okay, so therefore, it's a probability of I bar plus the probability of, not plus, again, multiply probability of T bar. Okay, so how to get I bar and T bar? Okay, class, you have the probability of I and you have a probability of T. So to get I bar is, you just do it what? Because, okay, the total probability of each event must be 1. Okay, 1. The total of each event must be 1. So to get the I bar, for example, I bar kat sini, okay, you must do 1 minus with 0.92. 1 minus 0.92. So what do we have here? 0.08. So this is the probability of I bar. Okay, class? Okay, 1 minus the probability of I. To get I bar, you must do it 1 minus it. 1 minus. Okay, to get T bar, 1 minus 0.88. So you have 0.12. So 0.12 is your probability of T bar. Okay, so you solve it. So you may get the answer 0.0096. Alright. Okay, class. So this is about the multiplication rule. Okay, the example. So you may do the exercise or you may try again your example. Okay, and then okay, we have another one actually, addition rule. So I have the example here, but I forgot to include in this slide. So maybe I will do another video. Okay, so you may watch out the next video lah for the example for addition rule. Alright. Okay, class. That's it. Dah.